Okay, now, our equation in every case is going to be y double prime plus y equals the applied force as a function of t. And as we know, using just standard techniques for a second order equation, linear equation in this case, depending on your applied force, if your applied force is nice enough, we can use undetermined coefficients, variation of parameters, inspection in some cases, in order to determine what your solution is. Okay, that's not where we're at in the course right now. We're into Laplace transforms. So let's just do the Laplace transform for the case where y prime of 0 is 1, f of t is 0. F applied, this is the applied force. So no applied force, just a freely swinging pendulum that has unit velocity at the first instant. And maybe that velocity is delivered through an impulse, or maybe we have one that's already swinging and we just decide to start our timer at the instant that it passes through equilibrium, moving in the positive direction. Okay, so here we have it. Okay, so we're going to Laplace transform this. We're going to get the Laplace transform of y double prime plus the Laplace transform of y equals 0. Well, the Laplace transform of y double prime is s squared times the Laplace transform of y minus y prime of 0 minus s y of 0. And I'm assuming that we've done some of the basic work of Laplace transforms, so we know these things. But this is very easily derived by the definition of Laplace transform and a little integration by parts. Okay, so anyhow we get this, and then L of y equals 0, and this gives us s squared plus 1 times the Laplace transform of y. Y of 0 is, where did I say it? I didn't say it. No, I did. Y of 0 is 0, so that this term doesn't come into the picture. And then it's minus y prime of 0, which is 1, that equals 0. And we end up with just a little easy rearrangement. Put the 1 over here, divide by s squared plus 1. And we get this, so y is the inverse transform of s squared plus 1, which should be familiar to us by now. We get the sine of t as advertised. Now if we want to let y prime of 0 equal 0 and y of 0 equal 1, what's that mean? That means your position at the initial instant is out here at unit distance in the positive direction from the equilibrium position. And y prime of 0 is 0, means it's stationary or stopped at that point. So maybe it's been oscillating and you start your timer when it gets here. Okay? When it gets to this point. That's your t equals 0 instant. Well, this makes y of 0 1 and y prime of 0 is going to be 0. What you get is almost the same equation, and I'm not going to write it all out because it's very straightforward. You should be able to write this out, except you're going to have a 0 here and a 1 here, which means you're going to have an s where you had this 1, which means you're going to have an s where you had this 1, which means that L of y is s over s squared plus 1. So y is the inverse transform of s over s squared plus 1, which is a cosine of t. Now you might want to go back to the derivation of these transforms, the transform of the sine, the transform of the cosine, and see where the s comes from here, and instead of the 1, see why you get a 1 here and an s here, and maybe even reflect a little bit on how that could be related to our physical interpretation and our physical intuition. Be a good thing to do. Unless it's required, nobody in a course is going to do that, but if you're doing this out of interest, might be something worth doing. Okay, so we have these possible models, and of course this corresponds to this situation. Okay. Now we modify these situations by putting other conditions on it, or by having a non-zero f app of t. We could get this one, incidentally, by starting our timer not here, but starting our timer here. In this case, y of 0 would be -1, y prime of 0 would be 0, and you just end up with the negative of the s over s squared plus 1, which would give you the negative cosine, which is like this. Okay, well, we want to understand that pretty well so that we can move forward with the consideration of what happens if we apply a unit impulse at the right point. And then we can talk about applying lesser impulses or a series of impulses. So we're going to go on with that.